I'm Yasir Iqbal. I'm an assistant professor in the Department of Physics at the Indian Institute of Technology in Madras. I started my position here in the summer of 2017 after having spent a long postdoctoral career in Europe, in Germany and Italy. But my first steps in research actually were taken in France, where I did my PhD. I embarked on exploring, topics in theoretical condensed matter physics, which has been my research area ever since. I went to Toulouse for my PhD in the fall of 2009 under the supervision of Dr. Didier Poilblanc at the Laboratoire de Physique Théorique at the University Paul Sabatier in Toulouse. I sort of straddled along various problems in the field of quantum magnetism and mostly employing, state-of-the-art numerical quantum many-body methods to approach these problems. So I have over a long, decade-long sort of, association with the French academic system. Having spent 3 years there for my PhD, I got to know many researchers working in this domain, and ever since I've maintained contact with them. And after I joined here, I wanted to restart my more active collaboration with the research group in Toulouse and also in other places. And it was a great opportunity that I learned of the CEFIPRA, collaborative scientific research proposals that are regularly advertised, and that was actually a great opportunity I thought I should, explore. And together with my PhD advisor, Dr. Didier Poilblanc, we wrote a joint project which thankfully was accepted in my first application itself, and that was sort of great excitement for both of us that we could, after my PhD years here, I could now collaborate with my advisor and we could, have some young, bright PhD student from India or France to work on some problems of common interest. So this was a great opportunity which we are really enjoying. And so the CEFIPRA project that we've been granted was written around the theme that we want to explore exotic phases of quantum matter that can arise in various platforms, in particular what I've called as frustrated magnets. So as I mentioned before, my area of research has been trying to explore what are the new states of matter that can arise in magnets when they're cooled to very low temperatures. So this is a field, a very sort of budding field of frustrated quantum magnetism. And there are various directions in it and various directions to look for, these novel states of quantum matter. So traditionally, when we think of different states of matter, ordinarily what comes to our mind are gases, liquids, and solids, which are typically very well understood within the conventional paradigm and conventional theories. However, over the last few decades, it's been realized that matter is actually very rich. There are, very many new types of exotic states whose properties differ very completely from what our traditional understanding is of, solids, liquids, and gases. And these go by the name of quantum spin liquids. And these are sort of really elusive creatures which are found at extremely low temperatures, very hard to detect experimentally, and more so there does not exist very well understood theoretical frameworks by which you can predict their properties or understand, their various features. And there have been claims and good evidence in experiment that they are found in certain quantum materials. But what is lacking is actually an understanding there and of their behavior, a microscopic understanding. So what we set to embark with this PhD student and together with Dr. Didier Poilblanc is to look at another very promising platform which goes under the name that the people experimentally of late have realized these ultra cold atomic gases made of alkaline rare earth atoms, which are much more cleaner realizations of these frustrated magnetic systems and describe their interactions without the presence of quote unquote pollutants. And new states of matter like quantum spin liquids have been sort of claimed to be realized in these setups. So there's a great synergy between theory and experiment. But on the theoretical side, we wish to do a modeling, try to understand the microscopic frustrated mechanism that arises in these microscopic interaction descriptions of these systems, which goes under the name of SUN Hamiltonians. And the goal is to use employ and develop state-of-the-art numerical quantum many-body methods, specifically Monte Carlo methods and flavors thereof, employing variational wave functions, which has been my focus of research ever since my PhD days. And also the collaboration with the Toulouse group, which has a great diversity and expertise of a range of state-of-the-art numerical methods, ranging from exact diagonalization techniques to density matrix renormalization group to various flavors of tensor network answers. So the goal is that the student in Toulouse will collaborate not just with the co-PI in France and myself doing the variational Monte Carlo, but will also get exposure to other techniques, and will interact with the other professors there, and learn and pick up and have a broad arsenal of techniques to handle this project. And I think so. I'm really thankful to CEFIPRA for having given this opportunity to really develop or restart this intense collaboration with the French research groups. And it also involves mobility for me to spend a month every year in France, which is a great opportunity, to interact not just with people there, but also around. And I think this is a unique platform of CEFIPRA, and I hope that they really grow more, and people in various branches of science, mathematics, and others take use of this opportunity to develop and foster collaborations with one of the strongest scientific systems in the world, France, with which we have had very long historical ties. And I would also like to thank CEFIPRA for giving us actually, when we applied for this Indo-French collaborative scientific project, we had also envisaged an Indo-French workshop on recent developments in frustrated magnetism. And that was also granted. So we are supposed to hold in a couple of months an Indo-French workshop in Bordeaux together with my French organizers, which will also be a great platform, I'm sure, for a meeting point for sort of furthering collaboration, fostering new collaboration, laying the seeds of new projects. When Indian scientists, we have about 15 of them who will travel to Bordeaux to participate in this workshop, and also Indian students in France as well as Indian students in India are most welcome, as well as French students.
Long live India and France friendship.